Hello everyone, I am Shubhra Pancha, Assistant Professor, Department of Computer Science and Engineering, BADS, VP Dr. PG Halkatti College of Engineering and Technology, Vijaypur. So, in this semester, I am handling you Computer Networks Laboratory. So, in this Networks Laboratory, it comes with two parts. The first part comes with the network simulation, wherein you can execute some simulation experiments. So before, so what you need to do is, so it takes some basic factors like bandwidth, then frequency, so all those things. So by applying and after that bit rate, so by applying all those, so you need to simulate some experiments that comes with the first experiment, and all those six experiments you are going to execute it in ns2. So but I'm not explaining those, so those experiments will be explained by Kattimani madam. So now I will explain the second part that comes with six programs. Those programs, that is six network programs, those programs will be executed in Java. So I will start with the first program. So that is, so totally there are six programs. The first program is CRC. So uh, finding error detection and correction. Second one is shortest distance algorithm. Third program is client server programs using TCP. Fourth one is again client server program using UDP. Fifth one is RSA algorithm, that is encryption algorithm, public key encryption algorithm. Then after that, we have one more network program, that is leaky bucket algorithm, leaky bucket program. So these six programs you need to execute in Java. So in that, I will explain the first program now. So the first program, I think uh, all of you are aware of how to execute the programs in Java. In the last semester, you have done that algorithm lab. So all programs in algorithm lab executed in Java only, and that too in NetBeans in the lab. So this time also you are supposed to execute these programs in Java only. So there is no difficulty in execution. So by using that NetBeans tool. So now what I will do is I will simply explain the programs. So first program, write a program for error detecting code using CRC CCITT. So in the last semester you might have studied data communications. So that is basics of data communications. In that, so you have studied CRC. So CRC is nothing but finding finding encrypted data by using CRC, by applying encryption and sending it to the receiver. So there, what you will do is, so you'll consider the data, and for that data, you'll consider another data that is considered as a divisor. So that original data is divided by the divisor. And here, very simple things, three factors will come. One is dividend, and the second one is divisor. Third one, what you are going to get is reminder. So whatever you are going to get, that reminder is nothing but CRC, and that CRC you are going to append it to the original data and send it to the receiver. So what receiver does is, again receiver applies the same procedure to retrieve reminder. If reminder is 0 at receiver, then whatever the data sent from the sender is correct. It is not altered in between sender and receiver. So this is what CRC. So let me discuss the procedure of that CRC, what we need to do in that CRC. So here, that what I said, the something which is in the middle is called as dividend, and this one is divisor. So and whatever we are going to get at the end after dividing is nothing but your reminder. But so one question is, so which bits we are supposed to take it in the dividend, and so this divisor is already given. There are standard divisor, also standard divisor polynomials. We can also call this as generator polynomial. So in this, now I'll tell you so how to perform division in the sense it is a normal, it's not a normal division. So what you will do is you have to perform the XOR operation between this this divisor with this data bit. So what we have to do is so this is just an example how to perform XOR operation. So still the procedure is there, I'll tell you. So what you will do is you have to divide this dividend bits with this divisor. So that is here simple thing. There is a XOR operation between this data with this divisor. So there is 10011. So what you have to take is simply the first value is the carry bit is 1. Then we have to write as it is here 10011 and perform XOR operation between these. 11 is 0, 11 is 0, 00 is again 0, 10 is 1, and 11 is again 0. And we have to take remaining bits and we need to perform the same operations again. We have to do this same operation until we need to get the bits which are less than this divisor. So here we got 4 bits and here we got divisor as 5 bits. So and we have to decide that those bits are the remainder. So this is a normal operation. But before calculation of CRC, what we need to do, what procedure we need to apply. So here you can see this. Assume that some message is given. Say for example, message bits are some message is given to those message bits. So say for example, message as 1011. These are the data bits. Assume it 1011. So now for that message, we need to append some number of zeros, that is C0 bits. So what actually that C is, I will tell you. C0 bits. So this augmented message is dividend. So initially assume that this is very important here. If data bits are 1011, then we need to append C zeros to those data bits, and after appending what we are going to get it, that is nothing but augmented message. So what is C then? That we need to understand. C is nothing but, in the previous example only we'll consider that C is nothing but the total number of bits in the divisor. So the total number of bits in the divisor is 5 here. So what we need to do is, say for example, our data bits are 11 0 1 1 0 1. Then we have to append 5 zeros to this data bits. Then we can uh, call that as a augmented message. Very simple. So here in this, now the next statement you can just observe it. A predetermined C plus 1 bit binary sequence. C plus bin C plus 1 bit binary sequence is what here? It is your generator polynomial. It means that in the previous example, this is after conversion only. So this is divisor bits are C plus 1 binary bits. C plus 1 binary bits in the sense C is 4 and plus 1 which is 5. So totally 5 bits. So what I told earlier is we need to append 5 zeros. So it's not 5 zeros, it is 4 zeros. So this generator polynomial comes with by subtracting by adding 1 to C, that is C plus 1. So totally 5. So then how many bits we have to append here? C bits. C in the sense it is 4. So you can see here a predetermined C plus 1 bit binary sequence called the generator polynomial is the divisor. The checksum is the C bit remainder that results from the division operation. So what is the total number of C bits here in the previous example, which is 4. C is 4. So we got the remainder as comes with 4 bits. So here in this, these are what I said in that first example. What we have is we are not supposed to take the generator polynomials of our own. There are some standard polynomials, that is, there are some standard divisor polynomials which are here in this. They have clearly mentioned the polynomial as CRC CCITT, which comes with what? 16 bits. So our C will be 16. You can see here CRC CCITT comes with what? 16 bits, but C plus 1 bit will be what? Is your generator polynomial. If you count here, this is 17 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 is your generator polynomial, or else it is divisor, and you have to use this divisor to divide some data. And what you have to do is how many bits of zeros you have to append? 16 bits. That is C. C is 16 here, and C plus 1 is 17. I hope you understood. So this is the same logic, so which is written in Java. So you can see here briefly. I'll explain it and I'll complete, and finally I will go to execution and I'll show you the execution. So now you can see this. So this is what buffer reader. This buffer reader is for reading some data that is in Java. So whatever we speak, that is in terms of objects and classes. So we have to take object br, which is considered from the class called as buffer reader, uh, taken for some scanf. So what you have to do is buffer reader br equal to new buffer reader of new input stream reader system dot in. This is for what? So whatever we need to read, we need to read the data in terms of br dot. So here you can see this. We need to define some arrays here. We need to define our data bits in the form of array, dividend bits in the form of again array, divisor bits in the form of array, which is maximum. Then we are going to get some reminder in the form of array. Then the combined, that is data plus reminder, that is augmented message, converted message, which is written in form of what? CRC. We need these five arrays, and along with that some integer bits. So how many data bits we are supposed to enter? That is a total number of data bits, total number of divisor bits, and total length. Total length gives you that augmented message, that is data bits plus C. I hope you understand it. So this is brief variables considered for this particular program. Now what we have to do is we need to enter the number of data bits. So before explaining this, let me show you the output screen first. So what actually the input and what output it produces, I'll show you that, then I'll explain that. So now you can see this here. This is output screen. So as usual, normal in command prompt, if you take it, that we have to take java c crc.java, then you have to run java crc. So initially what it takes, you have to enter the total number of data bits. So in your data there are totally 7 bits. So your data bits are 10110001. You have to enter uh, one by one. So total number of data bits are 7, and those data bits are here. Now enter the number of bits in divisor. So it is 3 here. So as your convenience, you can enter it. So they have mentioned that standard CRC CCITT, so that comes with 16 bits. You have to enter those 16 bits. You can use it. It will execute for that also. So here divisor bits are 101 101. So now according to this, how many zeros you are supposed to append to this data bits? So already this divisor bits are C plus 1. Then you have to append C zeros. It means that you have to append two zeros to this data. So you can see here 10 10 11 001, and after that these are two zeros. Totally there are three bits in divisor bits. Then you have to append two zeros to the data bits, which terms as augmented message. Then we have CRC code. So after calculation of that CRC, after dividing, you'll get reminder, and that reminder is replaced with these two zeros. Then what we have is 10110001. Then that two zeros are replaced with what? CRC. So now what we have to enter is enter CRC code of 9 bits. We are assuming that some bits are transferred to the receiver, and we are supposed to enter those received bits. If we enter the received bits are correct, then it will show you the no error. Otherwise, if you change any one bit among the CRC, then it will show you the error. So you can see here 101. So 1011001. You can see this. The last but one bit is 0, but here it is 1. It means that so somewhere else between sender and receiver, data has corrupted. So it gives you error. So another, if you want, I will show you that another run that is directly in the execution. So this is what the output screen. So you need to enter the number of data bits, then you are supposed to enter those bits. Then you need to enter the number of divisor bits. You are supposed to enter those divisor bits. Then it will show you the augmented message. Then you are supposed to calculate CRC, that is after division, XOR operation between and divided and divisor. Then after that, we'll get you need to enter the CRC once again, assuming that it is received at the receiver end. Then if you enter the CRC correctly, then it means that there is no error. If you enter by altering any one bit in that CRC, so it will show you the error. So here, whatever I explained, the same blocks are written in this Java here. I'll just simply show you here. Now in the first case, what is that? So you need to enter the data bits. So enter number of data bits, read it using what? Integer dot parse int of. So that's what I said, br dot read line. Then data equal to new int of data bits. Then what you have to do is after entering the number of data bits, you have to enter the data bits itself by considering the for loop. So that in that for loop, every time the values are read using the same integer br dot read line. This is purely Java. I already have done some programs in Java. Enter the number of bits in divisor, same thing. Again, what you have to do is you have to read the total number of bits using read line. Then you have to enter the divisor bits. That is again by using what? For loop. Then after that, you have to print the data bits. So what the data bits are? So for I equal to 0, I is less than data bits, I plus plus, then data of I. So every time it will print those bits. Then you need to print, these are all repeated code. You need to print the divisor bits. After that, what you have to do is after entering all this, we need to calculate the total length. Total length is what here? Data bits plus divisor bits minus 1, that is what? Augmented data bits. If the data bit contain 10114 bits, then if divisor bits contain 3 bits, then what the total length is? It is 6 here. So 4 plus 3 minus 1. 4 plus 3 minus 1. Divisor equal to new int of total length. Remainder equal to new int of. So what we have to do is we need to go for that divisor. Then we need to calculate that remainder, as well as we need to calculate that CRC. Then after that, so after these things, what we need to, so this is just we have considered the maximum size for this divisor, reminder, and CRC. So need not to worry about that maximum size. It will take that that array will take that. Now the next very important part is CRC generation. So what you will do is for int I equal to 0, I is less than data dot length I plus plus. Then what you need to do is every time you need to assign the data bit data of I equal to divisor of I. So that is what the exact division I'm telling. So here in this, now what we have to calculate here is, so after assigning all data bits to the divisor bits, so divide and after appending zeros are, so we need to print those, that is int I equal to 0, I is less than divisor dot length system dot out dot, that is we need to print those all divisor bits. Then after that, similarly we need to assign that divisor bits to reminder also, because whatever reminder we are going to get it which is equal to divisor bits, then we need to calculate, this is very important, we need to calculate reminder which is equal to divide of divisor, so that is divide of dividend comma divisor comma reminder. So three variables we need to pass to the method or function called as divide. And here it is. So the same logic that what we are considering here is, so for int I equal to 0, so let me discuss that divide function here. What is actually that divide is, here you can see this static int divide, int uh, divide and divisor reminder. So how it is calculated, so we'll take some current variable 0. So in that it's very simple, we so as per my discussion, there should be a XOR operation between divided and divisor. So for int I equal to 0, we need to put entire things in looping. I equal to 0, I is less than divisor dot length I plus plus. Then reminder of current plus I equal to reminder of current plus I XORed with divisor of I. So that will be calculated. So then we need to put some conditions here. Reminder of current if it is equal to 0 and current is not equal to reminder dot length minus 1, then we need to increment that current plus plus. Then if reminder dot length minus current is less than divisor dot length, then so as I said, so if the reminder bits are less than the divisor bits, then we need to stop the operation. So then finally we are going to get reminder, and wherever we need to calculate that reminder, we need to calculate, we need to call that divide function. So where exactly we need is, you can see here at the sender side, we need the divide function to calculate reminder, and after calculating that reminder, we need to append that divided and reminder so that we can get CRC. So once this is what we are appending here, once we get the CRC, then what we have to do is for CRC also we need to call that divide function, because that is at the receiver end. You can see this at the receiver also we need to call this uh, reminder. So if that reminder is 0, if that reminder is 0, you can see here reminder of I is not equal to 0, system we have to print it is error, it is not equal to 0. If it is 0, if it is 0, then it is no error. So here the program ends. So this is what CRC. Now what I'll do is I'll show you the execution. It'll take some time. Okay. So here I already have created. Wait, it's loading. So the first program is CRC. The same program is written here. So what I'll do is I'll execute it now. I'll finish it. Right click and go to run file. So output screen comes. So as I said, what you need to enter first is enter the number of data bits. So I'll enter it as 4. Okay, now what you have to do is you have to enter the data bits one by one. 1, 0, 1, 1. So your data bits are 1, 0, 1, 1. And after that, you have to enter divisor bits, which is, say, for example, 1. Sorry, I have entered the data bits. Total number of bits are 1. So we'll take anyhow. Dividend is again same. So because I have entered only the total number of bits are 1 in divisor, then the divisor bits are 1. So okay, now I'll run it again. Run file. Okay, enter the number of data bits 4, 4, then 1, 0, 1, 1. I'll enter the total number, enter the number of bits in divisor is 3. Then I'll enter those 1, 0, 1. I can see here ERC is 1, 0. You can see this first. Before that, how many zeros are appended to this? 1, 0, 1, 1, and totally 3 bits are there in divisor. So we have to append 2 zeros for the dividend. Then after that, CRC will be calculated every time that divide function will be called 1, 0, 1, 1, 0, 1. Then after that, so this is now what I'm entering is assuming that, wait here, we need to give the input here. I'll run it again. It will give the exception error. Okay, 4, 4, 1, 0, 1, 1, then B, right? 1, 0, 1. And after that, what you have to enter is CRC bits. So what I'll do is I will enter as it is, assuming that data sent and received as it is 1, 0, 1, 1, and the next bits are 0 1 0 1. You can see this build successful and no error, because whatever the data sent, which is received as it is, there is no alteration in between sender and receiver. So already I have shown you that how the error will be there, and so I am showing you now no error. So this is what CRC program. So in the next video, I will be explaining the second program, that is shortest distance algorithm, that is Bellman 4 algorithm. Thank you. Any doubts, any queries, you can ask me at any time regarding this CRC.